Okay, welcome back guys. We're going to look at the homework last night, and I have the log tables open with the prism formula that the volume is equal to the area of the plate times the height of the prism. And the plate is the congruent shape that appears on opposite faces and of course on every cross section in between. Okay, so let's jump straight in. We said we'd start off on question 8, work out the volume of each of these prisms. So it's told us it's a prism, it's given us a picture. I'm going to repeat that drawing into my book because it's good practice too. So question 8. Okay, so how can I draw this? We've kind of an L, up, over, up and out. We have a top of it, and drawing is fun, isn't it? And across, down, down and down. Okay, now let's put the values on. They're all in centimeters, so I'm just going to write the values. 6, there's a 3 here, and there's a 3 going backwards. Okay, so the important thing is we're looking at the plate to begin with, which now there's two ways to partition this. I can partition it here, or I can partition it down the way. I'm going to partition it here, but there is an alternative. So, and it's very important for you to understand that it's this L at the front is the plate, it's the B value. Okay, so I have 10 across and 4 up. So with the area of 40, I'm putting that in a square bracket to say it's an area. And here I have 3 up. Now I have to be careful, I have to calculate this length here from the 10 and the 6. So that's 4, making this 12. Okay, so I'll say B because it's what the letter we use here. B equals 12 and 40. 40 and 12 equals 52. Okay, now what's the height of my cylinder? Of my prism, sorry, it's 3. Okay, so H equals 3, B equals 52. Okay, so work out the volume. The volume equals 52 times 3. Put that in your calculator, you'd get 156. So the volume equals 156 centimeters cubed. That's question 8, part 1. Okay, oh, did I go off the screen there? I nearly did. Okay, so I'm going to push my log tables off page and we'll bring it back if we need it later. I don't think we will. Only maybe to say that this is an unfortunate enough looking prism, a difficult one to copy. So I think we might start using it on its side and just use something like a Toblerone as our prism, because a lot of people see this as a classical prism, but the surface is B and the height is H and the volume equals BH. In general, that's the only formula you need to worry about for prisms. Yes, sometimes you'll have to make a net and calculate area, but that's a different story. Okay, moving on to this one now. Okay, look, in order to do it nicely, maybe I should cut it out. No, I can't do that. No. Okay, so 7 goes here, 3 goes here, a bit of a difficult one to draw, I'll accept, and you wouldn't have to in an exam ever. Okay, important thing is I need to get the B plate, which is the front plate here. So what is it? Let's turn it into a long rectangle, which is 21, and a tall rectangle, which is 2 wide and 4 up. So that's 8. Okay, so now I've got my base plate. Base is what B stands for. and my base face area equals 21 and 8 equals 29, and my height equals 5. Okay, so the volume equals 29 by 5, which is equal to 145 centimeters cubed. Go on to question 9. Okay, the cross section of, there's another word. So when we hear the words cross section, that means B in our formula. And the cross section of this prism is a trapezium, and we'll find the area of the trapezium. Okay. The area of a trapezium given here on page 8, and we have, so this is one I want you to copy, base A. We call it base B because it's, if the trapezium was turned upside down, it would still sit with straight parallel lines, and the only values we care about are A, B, and the perpendicular height. Okay, and here's your formula. That's the way it's written in the log tables. Okay, and there's lots of ways of using it, so I think we'll just jump straight in. Right, what have we got now in question 9? We have 10 goes there, 8 goes here, and 4 goes here. Okay, so if we don't do any thinking about, well, what's a quick way of doing it or anything, like having this 4 and multiplying it by 18 giving me 36, or having both of them, 4 and 5 is 9, 9 by 4 is 36, but if we don't do any of that and we just do it in the calculator, we're still going to get 36. So let's just apply the formula. Now I just want to warn you, if you don't put a multiplication sign here and there's a number here, it won't work. So there's our multiplication sign and there's our 4. Okay, put it in your calculator any way you want, do any problem solving, either way we get, and we'll call it capital B, equals 36. Okay, so that's the first bit of the question done. Now we move on, find the area of this trapezium done, work out, so 36 centimeters squared. Work out the volume of the prism. Now for the volume of the prism we just have the base times the height. Now the height is 18, so we're going to take this and multiply it by 18, equals 36 multiplied by 18 equals, okay, let's see, can you see it? 36 times 18. Oh, this is so boring. I shouldn't be showing you this. 36 by 18. I think it's 648. Yeah. Equals 648 centimeters cubed. Scary, aren't I, that I knew that? You see, I knew 18/18s was 324 and I doubled it. Sorry. Anyway, question 10. This is a trapezium too. It has parallel plates. So it didn't even tell you that it's a trapezium, but it is. So they're my parallel plates. So work out the volume. The width of the swimming pool is the width. Oh yeah. So that's the height. So what this is like is you have a trapezium for B, and then the height is, the so-called height is 6 meters. Now they're all in meters, so we're good to go. So let's start off by getting B using the A plus B over 2 times H formula from a trapezium. So in that case we have 2 plus 1.5 over 2 the 2's in the formula, multiplied by, now the height for the trapezium is 15. Okay, so I think that'll come out as a fraction. We have 3.5. So I'll just do it in a slightly different way. I have 3.5 here. I'll times 15 it on top, and we'll divide it by 2. That's 3. We'll divide it by 2. Okay, and we'll get 105 over 4, or let's just shift equals that, 26.25 centimeters squared. And then the height of the thing is 6. The swimming pool goes back 6. So we have 6 by that. Now I've already got that on my calculator, so I'll just do times 6. Now yes, it says answer times 6. Now it says that, and now it's 157.5. So digit is the way to go there, because the fraction is not repeating, it's terminating after one decimal because of the fact it's divided by 2. Okay, so that one's that one done. Work out the volume of the prism. Of course it's in meters cubed. Find the area of the trapezium. That is not centimeters, surely, if it's a swimming pool. That is meters squared. Okay, cool. Question 10 is done. 1 to go now, lads. Okay, question 11. Question 11. Work out the volume of this prism. Oh my god. Right, so let's just do it here. I have to break it up into shapes that I would know. Let's try and break it up into a triangle and a rectangle. We have 8 by 6 is 48. I take the 6 away from the 14 to get 8 along here. 14 takes 6 is definitely 8. And this was 8 and this was 2, so the height was 6. So the area of the triangle here is half the base by the perpendicular height. 6 8 48 is 24. Okay, so now we're saying the base equals 48 plus 24 equals 72. Hopefully it's all centimeters squared. And now we're going to take that by 15. So the volume equals the base by the height equals 72 by 15 equals 72 by 15 equals 1080 centimeters cubed. Okay, that's the end of the homework. So I'll post a video, and I'll also post the pictures of the copy with the homework in it. And let's take a quick look at where we could go next. 494, 493, 495 into nets. I think we'll do 14 and 15 in class. We'll see, I'll figure it out. Okay, see you in the next one.